Hi everyone, and welcome back to the second part of the second day of our ARM Tech Talk series, bringing you some incredible innovations from CES, the Consumer Electronics Show here in Las Vegas. I'm your host, Tobias McBride, and I'm going to be bringing you some of the incredible ARM innovations at this show from our partner ecosystem. This ARM Tech Talk series really is the place for you to discover the latest trends, technologies, and best practices from the ARM ecosystem. So welcome back, and thank you so much for joining us. And as you look at CES, remember, take a look at what's being announced by our ARM partners and take a look at the latest tech at CES and ask yourself, when you see that announcement, is it built on ARM? Because more than likely it is. And we've had an incredible few days of tech talks already. I hope you managed to catch our live streams with Lenovo, where we looked at their brand new ARM-powered M11 tablet. We looked at RTI as well with their work on the software-defined vehicle. And we had the automotive theme carried on this morning with Tata Technologies. We talked about Sophie on the back of the new SDV Alliance announcement between Cavesa, Autosar, Eclipse, SDV, and Sophie. And we showed some really great demos. We've covered a lot already in these ARM Tech Talks, but we're not stopping there. We're carrying on the automotive theme today and the focus of this trend of the software-defined vehicle. And I'm thrilled today to be at our partner Green Hills Software's booth. I'm delighted today to be joined by Joe Faber, who's Global Technology Director at Green Hills Software. Thank you so much for joining today's ARM Tech Talk.
Thank you, Tobias.
How's CES been?
It's been fantastic. We've had great attendance in the booth, meeting lots of customers, meeting with lots of partners. It's a great show for us every year.
Absolutely. So I'm sure many of you on the webinar will, of course, heard about Green Hills Software. But for those who haven't, maybe tell us a bit more about who Green Hills Software are and how you build on the ARM-powered ecosystem that's out there.
Sure. Well, Green Hills Software is an embedded software supplier. We make compilers, debuggers, development tools for our customers that are largely developing on ARM-based SoCs. We make hypervisors, real-time operating systems. And I think one of the unique things about Green Hills and ARM is that we scale up from sort of the lowest level microcontrollers down at the Cortex M0 level, all the way up to the latest and greatest, Cortex A76AE class high performance computers that ARM is coming out for the automotive domain, safety critical, security critical markets.
That's absolutely awesome. It's great to see you scale all the way right from the M0 all the way up. So, this booth is really awesome. I've had the chance to go around it during the day. And actually, I'm going to run a little clip here. I'm actually get a chance to sit in a car, which is
Cortex A class parts. Integrity is used in lots of safety and security critical devices that are out there on the road today. So Nissan based that on a processor from Renesas. We worked with them. We actually have a functional safety team that developed a safety BSP for that system.
Right.
They used our development tools. Another unique thing about Green Hills is the tool chain is also going through a safety qualification process. So that's an example of a safety critical system in a car that's on the road today that really leveraged our operating system technology, our development tools, our debuggers, and is built on top of ARM and is out there driving on the roads today.
Absolutely. And as you mentioned about that functional safety, it's a critical component. It's so important in the automotive industry. Now, of course, you may have noticed on the call, we're behind some really cool ARM-based demos. So let's get into those now. And to do, I'm just going to switch cameras here.
Okay.
There we go. There we are again on the other camera. So, Joe, why don't you talk us through some of these really awesome demos? Let's start kind of left to right here. You've got a really great demo to start us off with.
Yeah, so everything that you're seeing in the booth on this demo wall is based on ARM technology. The first one, and there are 6 ECUs that are all connected in a network together. They're all talking to each other. They're also connected up to the cloud. So, the software-defined vehicle, that's all about being able to add new software features over time, push them down into the car, and get new functionality that can be monetized by the OEM and provide, really useful new features to the consumer. So the first system that we're going to focus on is this driver monitoring system, which is another important part of functional safety, especially in level 2 cars. The driver needs to be paying attention to the road. So this one we're running on a TI Satara AM62A. We've partnered with Smart Eye, who's doing all of the eye tracking software that you see in the system. When I'm looking at this screen, you can see my eye gaze is straight ahead. This won't be visible, but it's saying you're looking out the windshield right now. If I look up and to the right, that's where the rear view mirror is, and it knows that I'm looking at the rear view mirror. If I look down at the cluster, it knows that. If I then turn sideways and don't pay attention for a while, it knows that I'm distracted. But that computer has now broadcast a message out to all the other computers that might be listening on that vehicle network. And our instrument cluster has said, hey, there's a driver alert because I wasn't paying attention and talking to you. But that's one example of the connectivity that's happening between all of these ECUs. We actually have a radar chip down there from NXP. It's the S32R45. This car is the following distance that's on the cluster is also live. If you move the metal plate back and forth in that radar system, it updates from there.
Oh, awesome.
Moving on from that, both the instrument cluster and this IVI system are, a software-defined cockpit concept where we're using Integrity Multivisor, which is our virtualization technology for the Cortex-A class processors. This is running a full Android Automotive VM hosted on top of Integrity. So we can have a full IVI experience coupled with potentially safety critical applications, like the driver monitoring or other safety critical telltales that might be on this instrument cluster. Moving on down through the demos, definitely a central part of this demo is this S32G. It's the gateway processor from NXP. We have not only the Ethernet update where we're using a service-oriented architecture with some IP to broadcast and have subscribers to all of those critical messages, like from the radar and the driver monitoring system. It's also connected over a CAN bus. And inside this cabinet, we have an S32K3, which is a Cortex-M class processor that's running a battery management system. That is, all of that data is going through this central gateway and being pushed up to the cloud. And you can see in this web browser, this is live data that's coming from all of these demos. And so when I was over there in front of the driver monitoring system and I was being distracted or looking around, that data is also being pushed up to the cloud. So not only does this eSync server provide an OTA update system to allow those vehicle updates over time, but it's also providing diagnostic information. So it's a bidirectional, you can push and pull data. I guess moving along, there's certainly another trend that we're seeing in automotive right now, which is new zonal architectures.
Yes, absolutely.
Now we actually have two of these in the booth. There's one from ST that's over there, the SR6, but this one is another NXP device, the S32Z, for zonal controller. And on this one, we're running our Type 1 microvisor hypervisor, which can host any guest operating system. In this particular space, there's a lot of classic AUTOSAR functionality on various microcontrollers throughout the car. And we're able to bring all of those different operating systems as virtual machines onto this one zone controller and host them on microvisor. Additionally, we're providing the development tools that allow engineers to quickly debug and also optimize performance for these types of processors. And then if we move down, again, the final one, I've already pointed it out, but down there is our radar processing system. And we're also highlighting some of the development tools that we use for optimizing and debugging these types of systems.
That is awesome. It's so great to see all of these different trends and technologies we've been talking about. The software-defined vehicle, we talk about zonal controllers, functional safety, all these different critical apps that you've been talking about. I love the driver drowsiness one. That's great. I'm also a big fan of the music that's currently paused on there at the moment. Used to be a Muse fan back in the day, so it's great to see that as well. Good music taste here on the Green Hill Software's booth. So these demos are awesome. Thank you for showing them. This is really great. Let's switch back to the other camera and wrap up here.
Okay.
So that was, as I say, it was really, really great to see all these different trends. Are there any final things that you would like to highlight to the audience watching on our ARM Tech Talk today?
Well, I would say that, Green Hills has a couple of pillars that we've built the company on. One of them is developer productivity. So it's certainly a trend in automotive electronics that the complexity and the amount of software is just scaling up massively.
It really is, yeah.
And so Green Hills offers a lot of technology to help contain that complexity, to address safety in the midst of that complexity. So our Integrity RTOS, again, it goes through these safety certifications to the highest level, ASIL D, against ISO 26262, which is the functional safety standard for automotive. And it's a separation kernel. So it allows you to have small, simple, safety critical apps hosted alongside these more complex, maybe internet connected applications, and do that in a safe way. So that's one of the trends. But the other one is developer productivity. So we didn't get too much into the tools,
Sure.
but we've got some great tools for system integration where, you know, on Microvisor, that Type 1 hypervisor, you're bringing multiple guest operating systems with all of their apps and being able to visualize how those things are interacting with each other and see where performance bottlenecks are, you know, where you might have issues in the software. That's another really important focus as the software complexity grows. Having excellent debug tools to be able to find and quickly fix bugs in software becomes really important for making those start of production dates.
It really does, absolutely. So that's really great to hear. And of course, so you're in the West Hall, booth 6601.
We are.
So that's much easier to say than ISO 26262. I can't even say it. So really, really appreciate you joining for today's ARM Tech Talk. That wraps up day 2 of our ARM Tech Talk live streams. And as you can see, we've seen so much innovation in the space of automotive, all pushing this idea of the software-defined vehicle and so many more trends as well. I hope you've enjoyed it just as much as we have. Tomorrow, we're going to be hearing from Tier 4 and some really cool work they've been doing in automotive as well. So do check that out. We're going to be joined at 10 a.m. Pacific then. We also have a special guest influencer, Jeff Geerling, for our evening slots. I think it's going to be around 4 o'clock. So do join that one as well. We're going to wrap up CES there as well. So thank you so much again, Joe. Really appreciate today.
Thanks for coming to see us.
No, really appreciate it. And thank you so much for joining. We'll see you again tomorrow at 10 a.m. for the Tier 4 ARM Tech Talk. Have a great rest of your evening and enjoy the rest of CES. Thank you so much, everyone.